Let's talk a little bit more about the derivative of a function. So here I'm saying that y is a function of the independent variable x, y equals f of x. There are a lot of different notations for the derivative of a function. I tend to just use 2 or 3 myself, depending on context. But depending on what your major is, there will be different conventions for talking about derivatives. So the one that we'll be using a lot is f prime of x. Again, this is my notation to indicate the derivative of the function f with respect to the variable x. Less common, if I'm moving left to right on this slide, less common is the notation y prime. This is certainly allowed. So because y is equal to this function of x, I can just use y prime as my shorthand for the derivative. Now, the next couple of these are using a new notation. So the next one is dy on dx. So this looks exactly like those differentials I was calculating in my lectures last week. So if I ever see this symbol, it's not actually a fraction, again, because differentials are not real numbers. This is standing for the derivative of y with respect to x. You can also do this for df or on dx. So this notation comes to us from Leibniz. He's the guy who came up with this symbol. And it is meant to invoke this idea of comparing the infinitely small change in the function f compared to the infinitely small change in the independent variable x. Now, the next item here, d on dx, f of x. This is a little bit more precise. So the f of x here is telling me that the function is called f, the variable is called x, and this symbol here is the differentiation operator. Differentiation is the act of calculating a derivative. So this thing here is an operator. You give an operator a function, and it gives you a new function back. So here, if I give the differentiation operator the function f of x, it gives me back f prime of x. This symbol is supposed to still be invoking this differential idea, but please keep in mind that anytime I'm using this symbol, I actually mean the limit of the difference quotients at the coordinate x. The very last 2 symbols on this slide are correct, but they are not as common when you're working purely within mathematics. You might see these more frequently in, say, physics or something. So the capital D is just a different way to write the differentiation operator d on dx. The reason I like the d on dx better is because the dx tells me what variable I'm using for my function. It has to match the function that I'm giving to the operator. If I just write capital D, then that's sort of implicit. And one of the workarounds is that you can add a little subscript x to the differentiation operator capital D, just to say, oh yes, the variable is x, it's matching the variable of the function. But I won't be using these two notations on the far right as often. Most of the time I'll be using the f prime of x or the d on dx f of x. I'll sometimes use this dy on dx because I find it to be, reflective of this infinitesimal idea, even if that doesn't actually work out in day-to-day calculations.